So in this question, you're given two statements. First statement is that if P1, Q1 and P2, Q2 are two focal chords of the parabola y square is equal to 4x, then the locus of point of intersection of P1, P2 and Q1, Q2 will be the directrix of the parabola. That's the first statement. And the second statement is that locus of point of intersections of perpendicular tangents is the directrix. So out of these two, the statement 2 is obvious. The statement 2 is a standard statement in your theory. So S2 is true, there is no doubt about it. If you draw perpendicular tangents, both of them will meet on the directrix. Now let us try to see if the statement 1 is true. So what he is saying is, so if you have a parabola y square is equal to 4x, so this is y square is equal to 4x. Now let us have any two focal chords, let this be P1, Q1 and let this be P2, Q2. They have two focal chords, and what is being said is if you join P1, P2 and Q1, Q2, these two lines will meet on the directrix. That's what you're asked to prove. The locus of point of intersection of P1, P2 and Q1, Q2 is the directrix. So as these chords are moving, you're asked to see whether this point moves on the directrix or not. So right now I don't know, we'll have to do this. So how do we construct this mathematically? So for mathematical constructions we need to assume some variables. So what I do is, so let us take the parameter of P1 as T1 and the parameter of Q1 as T2. So let us take this as T1 and T2 and let these be T3 and T4. So let the first focal chord be defined by T1 and T2 and the next be by T3 and T4. Now we know that if P1, Q1 is a focal chord, then the product of the parameters have to be equal to -1. So the conditions are T1, T2 is equal to T3, T4 is also equal to -1. So these are the two conditions which has to be valid. Now if you join P1, P2 and Q1, Q2, so this is a chord which joins T1, T3 and this is a chord which joins T2, T4. So now what is the equation of the chord joining P1 and P2? The parameters are T1 and T3. So equation of P1, P2 is nothing but y times T1 plus T3 is equal to 2 times x plus a T1 T3. And what is the equation of Q1, Q2? So y times T2 plus T4 is equal to 2 times x plus a T2 T4. So these are the two equations of the chords. Now I want the point of intersection of these two lines and I want the locus of that. So if I want the point of intersection, let me directly subtract one from the other. So I get the y coordinate and from that I'll get the x coordinate. So what is the, if I subtract these two, you get y times T1 plus T3 minus T2 minus T4 is equal to, so 2x and 2x gets cancelled. So 2a times T1 T3 minus T2 T4. So from this the y coordinate will be 2a times T1 T3 minus T2 T4 by this. This implies y is equal to 2a times T1 T3 minus T2 T4 by T1 plus T3 minus T2 minus T4. So this will be the y coordinate of the point of intersection. Now what will be the x coordinate of the point of intersection? So if you put this in the place of y, so x will be y times T1 plus T3 by 2 minus a T1 T2. So 2a times T1 T3 minus T2 T4 divided by T1 plus T3 minus T2 minus T4. This is y into t1 plus t3 by 2 minus at1 t3 minus at1 t3. Now if we try to solve this, let us see what happens. So this is the x coordinate of the point of intersection. So if this statement has to be true, this x coordinate has to be equal to minus a for all t1, t2, t3, t4. So whatever t1, t2, t3, t4 we select, the x coordinate of the point of intersection should always be equal to minus a for this statement to be right. So now what is the simplification of this? So now let us try to simplify this x. So this 2 and 2 gets cancelled. So a is a common. So x is equal to a times. So t1, t3, so this bracket into this bracket. So you get t1 square t3 plus t1 t3 square minus t1 t2 t4 minus t2 t3 t4 minus t2 t3 t4 minus this a has become common, so I'll have to multiply this, minus of t1 square t3 plus t1 t3 square minus t1 t2 t3 minus t1 t3 t4 divided by t1 plus t3 minus t2 minus t4. That is equal to, as you can see, t1 t3 square t1 square t3, t1 t3 square t1 t3 square gets cancelled, and we know that t1 t2 is equal to minus 1. So this is equal to minus 1. Similarly, t3 t4 is also equal to minus 1. So t1 t2, this is minus 1, t3 t4 is minus 1. So if you substitute the values of minus 1, you get a times, so this becomes t4, and if you put this as minus 1, you get plus t2, and if you put this as minus 1 again, so minus t3, and you get minus t1 divided by t1 plus t3 minus t2 minus t4. As you can see, these two gets cancelled out, leaving a minus 1. So leaving a minus 1, that is equal to minus a. So can you see that the value of x is always equal to minus a, irrespective of what focal chord you take. That means the locus of the point of intersection is the directrix, which is true. So the first statement is also true. So now both the statements are true, but the second statement is not in any way a correct explanation for the statement 1. So that should be the answer. Thank you.